Kia ora Year 12 and 13. This is a question from the A-level test that I did this week, but if you're watching this and you're doing level 3 calculus, I think both of these questions are good, harder level 3 integration and differentiation questions. So don't hit delete or whatever you hit on YouTube. So the first part of the question here is an integration one, and the second one is a differentiation one. So I want to take a look at what we've got before I start. We've got a curve of y is equal to this trig thing here, right? So we've got just a part of this curve, and we're told that x is between 0 and pi on 2, and its maximum point's up here. So the first thing we're asked to do is to use a substitution to figure out the area of that shaded region. And then the second thing we have to do is to find the x coordinate of m. So obviously to do that we're going to have to differentiate, set the derivative equal to 0, and then solve an equation. So it's reasonably obvious what to do, but the technical bits in here have got a lot of little things to think about. So let's start off by looking at this integration using substitution, and then for the differentiation I'm going to work through it in two different ways. So let's start here. Y equals sine cubed x root cosine of x. So the area will be the integral between pi on 2 and 0 of sine cubed x times the root of cos x dx. We've been told what substitution to use, so we can just get on with it. So let u equal cos x. We can differentiate to get du by dx is equal to negative sine x. We know we have to replace this, so we're going to separate these variables and get du is equal to negative sine x dx. So we can see in here we've got the dx here, and we've got sine cubed x here. So what we have to do is to split this up so that we can substitute this in. We also know that we're going to have to change our limits of integration. So my x limits are pi on 2 and 0. U is equal to cosine of x. So cos of pi on 2 is equal to 0, and cos of 0 is equal to 1. So this is what we've got now. Just leaving it in x form to start with. We've got sine of x times sine squared of x times root cos x dx. So this bit here that I'm underlining is going to be negative du, and this bit is root u. But what about the sine squared of x? Well, we know that we've got u equals cos x, so we need to use a trig identity to transform this one. We've got sine x times 1 minus cos squared x root cos x dx. Finally, we're ready to do all of the shifting over to u. So the limits are now 0 to 1, and sine x dx is equal to negative du. This is 1 minus u squared, and this bit is root u, or u to the power of a half. Now, when we've got limits from b to a, if we flip the limits over, we reverse the sign of what's inside. And that's done really well in delta in one of the integration chapters. I'm going to rewrite this as this, the integral from 1 to 0 of just this expanded. So u to the power of a half minus u to the power of 5 over 2. Integrating that's pretty straightforward. We get 2/3 of u to the power of 3 over 2 minus 2/7 u to the power of 7 over 2, evaluated at 1 and 0. So that gives me 2/3 minus 2/7 minus 0 minus 0. Combining this gives us 14 minus 6 over 21, which is 8 over 21. So that's that question finished. Let's have a look at the next one. So we have to find the x coordinate of m and give our answer correct to 3 decimal places. And you can see that this is what we're dealing with. So it's a little bit messy. There are two ways to do this. There's kind of the obvious way, which is to use the product rule. which I think is fine in this case, except that students tend to make a number of small errors in here. So one way to go is the product rule, but the other way we could do this is to use log differentiation. And log differentiation is a technique that we talk about a lot in scholarship calculus, which is based on implicit differentiation. So it goes like this. We're going to take logs of both sides, and then we apply the log rules from year 12 or level 2 before we do any differentiation. So we have the log of y is equal to 3 log of sine x plus a half log of cos x. And now we differentiate with respect to x. So here, differentiate with respect to y, 1 over y, times dy by dx. And here we'll get 3 over sine x times cos x, the derivative of that, plus 1/2 over cos of x times negative sine x. And that has to equal 0. Well, that's not quite right. Actually, dy by dx has to equal 0. So dy by dx is equal to y, which is that, times this. Now I'm going to put this into a single fraction. No, I'm not going to do that. I'm just going to do this first. So 3 cot x minus 1/2 tan x. Right, so it's just a different way of doing it, and I think it's sometimes useful to see two ways to do the same question. So we're going to work this one through to the end now. So for a maximum, we have to have dy by dx equals 0. So that means that this can be 0, this factor can be 0, or all of this can be 0. So sine cubed of x can be 0, which would give me x is equal to 0. But we can see from the picture at the top that x is positive. Next we've got root cos x is equal to 0, which gives us cos of x is equal to 0, or x is equal to pi on 2. And we can see that's also not the maximum. So the point we're looking for is in between 0 and pi on 2. So we have 3 cos x over sine x is equal to 1/2 tan x, which is sine over cos x. That gives me 6 is equal to sine squared x over cos squared x. So 6 is equal to tan squared x. Root 6 is equal to tan x. And I can say that it's the positive root since x is between 0 and pi on 2. So we get to here, we chuck that into our calculator, and we get x is equal to the angle whose tan is root 6, which is 1.183. So that's one way to do it. Now I'm going to do it the way that most of you tried to do it, and some of you got there, and that's the standard way, just using the product rule. So dy by dx is going to equal, I'll differentiate this one first, so 3 sine squared x times cos x times this one, root cos x, plus the other way around. So leave the sine cubed x and now differentiate this. So it's going to be times 1 over 2 root cos x times the derivative of this inside function, which is negative sine x. And that has to equal 0 for a maximum. Let's clean this up. We've got 3 sine squared x times cos x to the power of 3 over 2 minus sine to the power of 4x over 2 root cos x, and that equals 0. So this looks bad, so let's think about what to do next. Well, we're going to get a single fraction. That's going to help us because we're going to be multiplying through by this. That gets rid of this horrible looking fractional power. So the whole thing now is going to be over 2 root cos of x. Here we get 6 sine squared x times cos to the power of 2x, right? It's 2x because it's 3 over 2 plus a half. Next up, we know that for that to be 0, we just need the numerator to be 0. So we can forget about this bit here. Don't worry about that. We're solving sine squared x into 6 cos squared x minus sine squared x equals 0. And you can see it's starting to look like the first version that I did of this. So sine of x equals 0, or 6 cos squared of x equals sine squared of x. So here, this gives me x equals 0, so this is not point M. We can see from the graph that M is strictly between those two limits. Here we've got 6 is equal to tan squared x, so we're back where we were. Root 6 is equal to tan x. So that should really say x is between 0 and pi on 2. So again, x is equal to tan inverse of root 6, which equals 1.183. Right, so hopefully people in the A-level class, that question should be feeling pretty straightforward now, even though when you first saw it, lots of you weren't too confident with it. Just make sure that you're really confident with basic trig derivatives, and if you're not, go and do the chapter in Delta that starts off with trig derivatives and the chain rule. Thanks for watching. Let me know if there are any other particular questions that you want video.